Okay, this is the review. Remember, if this is a negative, it moves it down to the bottom to become a positive exponent. And negative 7 squared is 49, so we'd have 1 over 49. Okay, part B, I can take 16 to the 3/4, and then exponent to an exponent, you multiply. So this would be to the 6. Okay, this is the same as the 4th root of 16 cubed. 4th root of 16 is 2. 2 to the 3rd power is 8. So I have 8x to the 6th. Okay, since I'll show some steps here. So we have this over 27 to the negative 2/3. Okay, now since they're negative, they're going to switch. So this goes to the top. It'll be 27 to the 1/3 squared. And this is negative, so it goes to the bottom. It'll be 64 to the 1/3 squared as well. Okay, the cubed root, 1/3 is a cubed root of 27 is 3. 3 squared makes 9. Cubed root of 64 is 4. And 4 squared is 16. Okay, number 7. What I personally like to do is get rid of the negative exponents first. So I'm going to move this one to the bottom. This one goes to the bottom. This one's negative moves to the top. Okay, that's the same thing as 5 squared over 5 to the 4th. And if you think 2 up there, 4 down there, 2 of them will cross out, so it'll be 1 over 5 squared. It would be 1 over 25. This one here, they're both the same bases, so I can take these and I can add the exponents. So this would be x plus 2, and negative 1/5 would be negative 2/10, negative b negative 9/10. When I add those together, since it's negative, I'm going to move it to the bottom and make it a positive exponent. And I can't really do any simplifying from there. This one, I like to take these through first. So this would be m to the negative 4, n to the exponent to exponent, you multiply, so 2. And then we'd have 4 to the negative 1/2, m to the negative 3/2, n to the first. I then like to get rid of the negative exponents, so I'm going to move that to the bottom. That stays on the top. This moves to the bottom. This moves to the bottom. And that stays on the top. Combining them, okay, this would be the square root of 4 is 2. On the top I have n to the 3rd. And if I add my m's here, when I multiply I add. So 4 would be 5.5, which would be 11/2. Okay, that's number 7. Number 8, we want to simplify these. Okay, so I'm looking for groups of 4. So I have a group of 4 there, so that answer is just 2. Okay, this would be the same thing as the cubed root of 2 over the cubed root of 3. Okay, remember we don't like the cubed root or radical in the bottom, so I have to multiply both the top and the bottom by something to get rid of it. So if it's cubed root, I need groups of 3. So I have a 3, I need 2 more 3s. 3 times 3 is 9. So I'd have the cubed root of 18 on the top, and 3 times 3 times 3 would be 27. Cubed root of 27, which is 3 3s, would just be 3. And I should look to see if 18, 9 times 2 would be 3, 3, and 2. No groups of 3. Okay, 18, 9 and 2, 3 and 3. So the square root of 9 would be 3 there. And I have the square root of 2 left over. I have 5 x's, looking for groups of 2 for square root. So I have x times x with 1 x left over. And if I have 8 y's, that would be 4 groups of 2 with none left over. Okay, so this one here, I'm going to do this. You can approach it different ways. If I multiply these together, that would be pq to the 3rd. Okay, and I can take a p out. I can reduce these. So I can say this is the 4th root of q to the 3rd and 4th root of p squared, if I divide just the p out. Okay, now I want to get rid of the radicals here. So I need a group of 4, so I have p times p, I need 2 more p's. So I have the 4th root of p squared on the top, and I have p to the 4th root of p to the 4th, which is just a p on the bottom. And at number 9, remember we can only add like terms, so I have to simplify these. Let's go 8 times 4, which would be 4 times 2. Okay, I square roots, I'm looking for a group of 2. So this would be 4 square root of 2x, 2 left over, and the x left over. Okay, that doesn't simplify, so we just have 1, it's like a 1 there. And 18 would be 9 times 2, which would be 3 and 3. So this would be 3 square root of 2x. Okay, so they're all 2x's. 4 plus 1 is 5. 5 minus 3. Okay. This one here we're multiplying, so if I multiply there, that's the cubed root of 8 plus the cubed root of 2 plus 4 cubed root of 4 plus 4. Okay, the cubed root of 8 is 2. 2 plus 4 makes 6, and those are not like terms, so I can just leave them there. Multiply, x times x is the square root of x squared, plus the square root of xy, minus the square root of xy, minus the square root of y squared. So these two middle terms cancel. I have x, not plus, but minus y. Okay, number 10, I want to rationalize the denominator, divide. So I have to multiply by the conjugate. Okay, so if I multiply on the bottom here, it'd be the square root of 11 squared, or 121 if you want to write that, plus the square root of 77, minus the square root of 77, minus the square root of 7 squared, or 49 either way. So this cancels out. This would be 11 minus 7. On the top, 14 square root of 11 plus 14 square root of 7. And the 14, 14, and 4, I can divide a 2 out of all those. So it would be 7 square root of 11 plus 7 square root of 7 over 2. Okay, now we're on page 307. We got the radical by itself, so I want to square both sides. So this would be x minus 5 times x minus 5, which is x squared minus 5 minus 10x, and plus 25. And square and square root cancels, so just 5x minus 1. Okay, I have a quadratic to solve, so I'm going to subtract that over, so it'd be minus 15x. I'm going to add that over, it'd be 26. This one you can factor. If you can't factor, use the quadratic formula. Be negative 13 and negative 2. So I get x equals 13 and x equals 2. Okay, then we have to make sure they work. Let's just say I plug the 2 in. 2 minus 5 is negative 3. I cannot have a square root equal negative 3, so I know that doesn't work. The 13, if you plug it in, will work. Okay, number 11. I want to get this radical to the other side. So we have this, and then we want to square both sides. This side's easy to square, that's just 2x plus 3. This one though, we got to multiply it by itself. Okay, so 1 times 1 is 1. 1 times that is plus 1x. Inside is plus 1 of those square root of x plus 1s. And there I have the square root of x plus 1 squared. Okay, because it's times itself. So if I simplify this, this would just be x plus 1. Okay, so I can add this 1 and this 1 to give me x plus 2. And then I have these two, which would be 2 of those adding like terms together, 2 of those square roots there. Okay, I have another radical I need to get rid of, so let's take all this other stuff to the other side. I'm going to subtract the x, subtract the 2. So I have x plus 1. Don't really need the parenthesis there. Is equal to 2 square root of x plus 1. You could divide by 2 or just leave it there, but now I'm going to square both sides. So this would be x squared plus 2x plus 1. 2 squared is 4, and this squared is just x plus 1 then. Okay, so if I distribute, get it equal to 0 because I have a quadratic, subtract that over, factor, I get x equals 3 and x equals -1. And check them to make sure, but when you plug them back in, they will both work. And number 14, I'm going to cube both sides to get rid of the cubed root. So I have x plus 9, and 2 to the third power is 8. Subtract your 9 over, you get -1. Plug it in, it does work. Number 20, you could write it as an exponent, or we can just raise it to the 3 halves. Okay, you multiply, and that times that is x to the first then. And this would be the same as the square root of 16 to the third power. Square root of 16 is 4, and 4 to the third is 64. Okay, now technically we should have 2 different answers, 64 and -64, because when you take the square root of both sides, you want to do the plus and the minus. So -4 cubed and 4 cubed give us our answers there. Number 26, if I rewrite this with positive exponents, okay, we can do that. Get rid of our denominators by multiplying by x squared. Those cancel. I'll have 3 minus 19x plus 20x squared. Okay, usually we see it the other way around, so I'm going to put the 20x squared first, minus 19x plus 3. And then from here, we're going to have to try and factor or quadratic formula or whatever method you want to use. I think it's 5x and 4x to give you 20, and then has to be negative and negative, 3 and 1, so that's 15 and 4, negative 19. Okay, so I get x is equal to 1/5 and x is equal to 3/4. Okay, this is one where we're going to use that x to the 1/4 is equal to a u. Okay, so we're using that substitution idea. So this would be u to the third. Okay, this is the same as 2/4, so this would be u squared. And this would be u to the first, and then plus 1. Okay, so, and then we can factor by grouping. So our factors would be u squared minus 1 and u minus 1. So if I set these equal to 0, and I can actually take these and plug them in, well, I'll do this. So I get u is equal to 1, u is equal to -1 from here, plus and minus 1, and this is just 1, so we get those 2 answers there. So now I can plug the x to the 1/4, I know will equal 1. And x to the 1/4 equals -1. Then when I solve this, I'm raising it to the 4th power, so I get 1. Raise it to the 4th power, that is 1 again, so x will equal 1. Okay, number 32, when we solve this, we're going to square both sides. I'm going to subtract that 13 over and divide. I know that x is equal to -2. Okay, now for the less than greater than part, we're going to look at the graph. Excuse me. So we can look at the graph of, let's get it equal to 0. So just subtract the 3 over. Okay, so we're going to graph this. And when you graph this, it looks like this. Okay, so we want to know where is it, and really, okay, when I subtract that over, we want to know where it's greater than 0, and then over here, it'd be where that graph is less than 0 we want to find, okay? So greater than 0, okay, so we know it's equal to 0 here at -2, because we got that right here. So then greater than 0 is going to be from -2 through infinity. And then less than 0, okay, so it comes down to here, but it doesn't just keep going. So to find what this point is here, the x of this, we have to set this 2x plus 13 equal to 0. Set this equal to 0 here. So we get -13 halves. So that's where it starts here. So from -13 halves up until -2, that's where it's less than 0. Okay, 38, I'm going to square both sides. So if I take this times this, it'd be the square root of 2x minus 4 quantity squared. That times that is 2 of this. Inside is another 2 of that. And then that times that is 4. And then this squared is just 3x plus 4. Okay, this is 2x minus 4 because it's squared and square root cancel out. If I add it to this 4 to it, those cancel out. So I have 2x plus 4 of this 2x minus 4 equals this. Subtract your 2x over. And square both sides. So this would be x squared plus 8x plus 16. Write it twice and multiply it out. This would be 16 times 2x minus 4. Okay, if it's a quadratic, okay, so 64 times 4, yeah, I mean 16 times 4 is 64. Okay, so x squared, I'm going to subtract the 32, gives me -24x here, and I'm going to add the 64 over, gives me 80. Okay, so now I have it equal to 0. Okay, you can factor this out. Let's see, 20 and 4. So now that x is equal to 20 and x equals 4. And they will both work when you plug them back in. Okay, so now for the less than greater than stuff, I'm going to take this equation and graph this. So I'm going to take this equation and I'm going to take this part and subtract it over. And now I have it equal to 0. So I want to graph that equation, so let me graph it. Okay, putting this in Desmos, you get a graph that looks something like this. We know that at 4 and at 20, okay, where it's equal to 0, we have that. So where is it greater than 0? Right here it's greater than 0 between 4 and 20. And where is it less than? Okay, from 20 and above. And then also from here to here. Okay, that keeps going, but this one's going to stop right here. To determine that, I take this 2x plus 4, 2x minus 4, set it equal to 0, and I get 2. So it's right here, stops there at 2. And so also less than 0 would be from 2 to 4.